Assalamu alaikum, dear students of class 10th. Welcome to the e-learning class of Forward Public School with your teacher Hubru. The topic we are going to discuss today is self-ionization or auto-ionization of water, which is present in the second chapter of your book, that is acids, bases and salts. Till now we have studied that an acid when dissolves in water produces hydrogen ion and a base when dissolves in water produces hydroxyl ion. What if there isn't an acid or a base in a solution or in water? Does water react with itself? So the answer is yes. Two water molecules react with each other and this is called as autoionization of water. To understand this, let's focus on this reaction where two water molecules are reacting together to produce these two ions. Here, according to Bronsted-Lowry concept, this water molecule is donating a proton and is acting as an Bronsted-Lowry acid, as Bronsted-Lowry acid is a proton donor. Here, this water molecule is accepting that proton, so that's why it is acting as Bronsted-Lowry base, because Bronsted-Lowry base is proton acceptor. As a result, this water molecule forms hydronium ion. Hydronium ion can donate a proton and can act as Bronsted-Lowry acid. So it is the conjugate or linking acid of this base. So base 1 and conjugate acid 1. These two are the conjugate acid-base pairs. Here, this water molecule forms, after donating a proton, forms hydroxyl ion. This hydroxyl ion can accept a proton and can act as Bronsted-Lowry base. So it is the linking base of this acid, acid 2, and its linking pair is conjugate base 2. Definition of autoionization of water. The reaction in which two water molecules produce ions is called as self-ionization or autoionization of water. A single water molecule ionizes as follows. A single water molecule gives H plus and OH minus ions. Well, water undergoes self-ionization to a very small extent. And two water molecules, when react together, they produce a hydronium ion and hydroxide ion by the transfer of a proton, which I have explained you very well in the previous slide. When water forms ions, it has an autoionization constant, and that is called as water dissociation constant. It is denoted by Kw. Its definition is the mathematical product of molar concentration of hydrogen and molar concentration of hydroxyl ions is called as water dissociation constant. It is written as Kw equals to molar concentration of hydrogen and molar concentration of hydroxyl ions. By using this constant, we can determine the concentrations of hydrogen ion and concentration of hydroxyl ions in a solution. In order to understand this concept, we will see the self-ionization of water at room temperature, that is 25 degrees Celsius. As we know that a single water molecule ionizes as follows. It gives an H plus ion and a single hydroxyl ion. So for this reaction, we can write Kc expression like this, as you have learned in your chapter 1. Approximately out of 1000 molecules of water, only one molecule of water dissociate into its ions. So the molar concentration of water almost remains constant. That's why we can write the previous equation like this, where we have written the molar concentration of water with the equilibrium constant Kc. Now this expression equals to another term, that is water dissociation constant Kw. Now putting this value in equation 1, we get Kw equals to product of molar concentration of H plus and OH minus ions. By conductivity experiments of pure water, it is calculated that the product of molar concentration of H plus and OH minus ions in pure water is always 1 into 10 raised to power minus 14 mole per dm cube at 25 degrees centigrade. Now, what are conductivity experiments? By conductivity experiment, we can check the ability of water to conduct electric current. Well, now we can write equation 2 as Kw equals to product of molar concentration of H plus and OH minus ions, which is equal to 1.0 into 10 to the power minus 14 mole per dm cube at 25 degrees centigrade. means molar concentration of H plus and OH minus ions equals to this term. So that water is neither an acid nor a base. So in pure water, the concentration of H plus ions is always equal to the concentration of OH minus ions. These both concentrations are always equal in pure water, as pure water is a neutral substance. So on this basis, we can write equation 3 as, equation 3 is this red one. So we can write it as H plus and H plus. Instead of OH minus ions, we can write H plus because both are equal. After writing this, these H plus becomes in square form. To remove the square, we can take square root on both sides. After taking the square root, this square will cancel this square root. It will become H plus, and its square root comes 1.0 into 10 raised to power minus 7. It means the concentration, the molar concentration of H plus in pure water is 1.0 into 10 raised to power minus 7. As both are equal, so OH minus ion concentration is also 1 into 10 raised to power minus 7. So in water at 25 degrees centigrade, this is the thing to remember, that at 25 degrees centigrade at room temperature, the molar concentration of hydrogen ion in water is 1 into 10 raised to power minus 7 molar or mole per dm cube, and molar concentration of hydroxyl ions is 1.0 into 10 raised to power minus 7 molar. Putting these values of H plus and OH minus ions in equation 2, this was our equation 2. After putting these values, that is H plus value is 1 into 10 raised to power minus 7 and OH minus ion value is 1 into 10 raised to power minus 7. Taking product of these both, multiplying them both, we get 1 into 10 raised to power minus 14 m square, which is our desired value. We got that after conductivity experiments that Kw is equals to 1 into 10 raised to power minus 14. This is the end of the topic. Dear students, try to practice this derivation by yourself so you can understand it well. Good luck. Allah Hafiz.